I want to show you part of their design requirements were that if conduct repairs integrity testing using 3D topography, imaging, and gamma density logging. This is what was required per the contract if they ran across issues, but yet we know none of that's happened. Also, this video is really going to be about exploring transverse cables and how I think they were the part of the problems not transferring the forces over to the longitudinal cables. And here you see a screenshot with the monitoring program that it was very important that they were going to monitor this deck system, and also the diagonals would be supported during transportation, that the members would be supported under the nodes. And we know that all the nodes were not supported during transportation. There was a couple of load points, but not under all the nodes. And here's the monitoring company, one of their tweets before they removed it. It shows the supports, and you can see they're not under the nodes. Now, there is allowance to allow Denny Pate to change, the plans, but he cannot change FDOT's requirements. They cannot be changed, but he has flexibility to do that. Also, the shop drawings, which I'm going to show now, must also be approved shop drawings by a independent review. And you'll see that, or be independently reviewed. You can pause these and take a look. That's the shop drawing. All right, thanks for watching. We're going to keep going. I am considering that this span was complete, and so detensioning 2 and 11 would be called for, or allowed, if you will, based on this being decorative, except for it said it would help with resonance. My consideration is that 2 and 11 are allowed to be detensioned at this point, and that the two other, and I'll show you just in a moment, the two other ports on each side of the canopy were designed to hold the two structures together, and that was about the size of that. Meaning, that's the meaning of the intent of those two other members, that they were not structural in that for this span, but the way to hold these two together, this being the expansion joint between the two, and this the intent, and this just tying the two together at the canopy. Decking was fully post-tensioned, as we appear to know. So at this point in the drawings where it says, right here where my mouse is, post-tension members to it will not be grouted and will be de-stressed after main span construction is complete. Do not remove bars. So does this also mean that they're supposed to detension after they transported it, or is this before transporting? I think this was, until after main span construction was complete. One of my theories is that the main span construction can't be complete until you also tie in the two decks together using the other two ports here. Tying it all in like an expansion joint, if you will. Pause it. There we go. So C2 and C3 are installed, and perhaps the intention of C1 and C4. C1 here and C4 there also. Again, just to tie two structures together, which means it was not, the intent was not to load bearing capacity. So that is what I'm leaning towards, the intent of C1 and C4. So could you detension at that point? Apparently, if that's the intent, and they address the wording in that it must be completed, and they would also have to adjust. Let me pause it, and I'll come right to what they should have to adjust also. So the detail states that not to be detentioned until the main span is complete. And then 2 and 11 can be detensioned. Going back over this D, circle D here, you see it, detail B. 16-inch diameter pipe round. This is B. This is that detail here. As you can see, it looks like you would be able to get to. It looks like you'd be able to get to the detention number 11 after all. And I said, I don't know how you would be able to do that. And I found this detail now, and apparently I didn't pay attention to it earlier properly. But it looks like you'd you would be able to detension after the pipes are installed. So this gives me a conflict of my one statement, but also a conflict of what I'm saying too, that you can remove detention 2 and 11 at this point, when I would now state that if you can get to it, well, this span's not complete until the residence detail is complete. This was stated somewhere that this helps with residents. So that would be a questionable thing. I'm going to show you what we're going to look at here is this main span again. These are the transverse longitudinal cables. See right here? Take note of, again, D1. We're going to visit this again. D1 is 471 kips. D2, which is next to it, is 745 kips. So recall these two. And most importantly, the transverse cables, recall this. The main span, all of them, 65 of them, will get 187 kips. And then it will be released at, so it's 489. So I want you to keep in mind that these numbers appear to be 70% of the ultimate failure number. Basically, that's the margin that they worked with consistently with all of the post-tensioning I've seen with the transverse and the longitudinal cables. So let's go from there. And then on this one would be the 162 on that end and 157 on that end. So pick your poison. What I'm going to show you is that we only have 150, you can call it 200 kips. We can round up if you like. 200 kips of resistance on the transverse cables. The transverse cables. And take note of the location of the... please allow me to take liberty in the next part of this video. I'm going to use a section of the video of the drawing to demonstrate the transverse cable. It is not the part of the literal part of failure in the drawings. Thank you. The base where they meet, the node area at the deck. Here are here's the longitudinal cables, and this would be D1, and D1 would be the same distance from center line over here approximately. They only show half the structure, and then you do it symmetrically. So you can see that it doesn't land. I talked about this. It doesn't land on land. It's not over top of the longitudinal cables. The ducting was a big issue for me here, where they put the plumbing, where they had nothing underneath it directly. So for this load to transfer over to this D1 and the D1 over here also, it would have to span the distance with the concrete and any metal reinforcement they have. And you could then add, you then add the two transverse cables that are close to it, this one and this one. And you can see it basically surrounds it. In this case, it looks like it's in line with it pretty good, pretty much, but the distance here is great. It's 1 foot 10 center line, as we recall roughly, and 1 foot 10 here. So you've got that 3 foot 8 inches. I think it's approximately from width to width that this load would have to start transferring over to the first transverse cable out the opposite directions. And to do that, they use the transverse cables to do that. But these transverse cables are only capable of holding what? So 200 kips and 200 kips, 400 kips. You know, they had a little more before failure. This is very questionable. They're not capable, I think, of transferring the loads without elongating these two here to make it over. Now that node on the underside, we don't have super details of it or the reinforcement, but we do have apparently a detail of how these transverse cables come under there. I'd like to look at this some more, but I can see where this would cause a deflection, cracking in the deck even around this area. In this case, we have a real video of failure, and it's right about here. You know, which is oddly, you know, it's like these two held up, and then forces didn't quite make it out to here. Only if it made it out, you know, and stayed on top of, only if it could stay on top of the longitudinal cables. You know, we'd have all these forces, but the transverse cable seems to be lacking. It's just, this is all theoretical, right? This is the way this whole thing was done, theoretical, and then put in operation. So my theoretical sorry about the noise in the background, is also theoretical in my values. I guess I'm a turn.